Welcome back to the Art Compass Academy. This is part 2 of Lesson 1. Understanding pH. I'm Susanna, and I've been a technical lab supervisor and senior embryologist for 8 years. pH level is important to enzyme function, as enzymes can only work within a certain range. Enzymes are biochemical accelerators. They speed up chemical reactions in the body. Their activity depends on pH. Each enzyme has its own optimal pH range, so if pH is too high or low, enzyme activity can be diminished or even blocked completely. For example, pepsin works optimally at a pH of around 2, which is highly acidic. In contrast, trypsin works optimally at a pH of around 8, which is more basic. Changes in pH can cause enzymes to denature, meaning that their structure changes and they are no longer able to function. This can be detrimental to biological processes that rely on enzyme activity, such as digestion, metabolism, and cellular respiration. pH is a critical factor in maintaining proper cellular function. For example, the pH of human blood must be kept within a narrow range of 7.35 to 7.45 for oxygen delivery and carbon dioxide removal. Enzymes involved in cellular respiration, such as cytochrome oxidase and succinate dehydrogenase, require specific pH ranges to function efficiently. Levels can impact the structure and function of cell membranes, transport proteins, and ion channels. Acidosis occurs when the blood pH drops below 7.35. This condition can be caused by a number of factors such as respiratory or metabolic disorders and can lead to symptoms such as confusion, fatigue, shortness of breath, and even coma. Conversely, alkalosis occurs when the blood pH rises above 7.45. This can also be caused by respiratory or metabolic disorders and can lead to symptoms such as muscle twitching, tingling in the extremities, and even seizures. A pH buffer is a solution or system that can resist changes in pH when an acid or base is added. It helps to maintain the pH of a solution within a specific range, even when external factors try to change it. Buffers work by absorbing excess hydrogen ions in acidic conditions and donating hydrogen ions in basic conditions, thus minimizing changes in pH. There are several buffering systems employed by biological organisms. Let's start with the carbonic acid bicarbonate buffer system. This buffering system helps maintain the pH of blood and other bodily fluids. Carbonic acid acts as an acid and bicarbonate acts as a base. When the pH drops, carbonic acid donates hydrogen ions to increase the pH, and when the pH rises, bicarbonate accepts hydrogen ions to decrease the pH. There's also a phosphate buffer system. This buffering system is found in intracellular fluids and urine. It works through the action of monohydrogen phosphate, which acts as a weak base, and dihydrogen phosphate, which acts as a weak acid. In protein buffer systems, proteins such as hemoglobin can act as buffers by donating or accepting hydrogen ions at their amino acid groups. This helps to maintain the pH of bodily fluids and intracellular environments. Well, that's all for now. Don't forget to log into the web-based Art Compass to download your certificate and claim CUs. We're looking forward to seeing you back for Lesson 2, pH, buffers, and embryo culture media.